Hello everybody, today we are gonna go over the linked list and we will start from the very basic, okay? So for the shape, in order, I will cover a little bit about pointers and then later on go into the linked list. And there are two types of memory exists in computer. One is static memory, the other one is dynamic memory. So C++ has limitations. You cannot grow here because it's stack. You need to say from the very beginning what is the size of this place. So if you want to create like integer size and you would like to get this size from user cin, I don't prompt anything, and if I want to create an array integer, let's say score, and with size it will give me compile time error because this is not constant, it's changing, and with compile time we need to know. If I make this constant int, then it's okay, but if you don't know the size of the data from the very beginning, then this is not going to work. So one of the thing is if you want to do handcraft linked list. Of course there's vectors, but we are learning linked list now today. So for that we have a struct, because we have your struct because everything is public. We call this a node, and this node has two parts in it. One of them is the data. You can say if you are going to hold integer like scores, I can say this is the data. It could be a string, it could be another class also. And node pointer, and we call this is to the next item. Okay, so if you want to visualize this, let me undo this one, and this is a node piece, and it has two parts. One of them the data itself. This is the data part, and we will have the other one is the pointer to the next item. Okay, let's try to do this in a second. So if I create a node, let's call this is a head node. So when I do this, this is created on the stack. Here it is. This is stack. Okay. This is dynamic memory heap. So this head is created somewhere, we don't know, but it is if the stack and pile on top of each other, it is somewhere here, let's say. But this is sometimes there's a misunderstanding. When you see pointer, you think, oh, this is should be on the heap, not this is on the stack. And then we will do this head equal to new node. Now this node is going to be created on here on the heap, because new means giving me a pointer, and this will be generated this node like above here. So one of them is going to be data, the other one is going to be pointer to the next one, and they have an address. Let's say this address is dynamic1, and this guy is going to hold this dynamic1 address. So we are going to point from here to this one. Okay, so this is the head which is on stack, and new node is here, and we don't have any data we put. So let's create a constructor here which will make our life easier. So I will be moving this to the side, so, and this to the left a little bit, and use our screen efficiently. If I can get this mouse moving here, and we don't need to see this part, right? So hide it here. So I will create a constructor, and it will take two parameters. One of them is integer data, the other one is node pointer next. You may say you are using the same name. As you know, C++, I can separate with this pointer. This data is equal to data of given parameters, and I will be just copying pasting, and next is the next of given parameter. So this is all cool. So now it's crying because when I created a multi-parameter constructor without default constructor, compiler gives up creating the default one for you. So my intention is go here and create, I will put some data, let's put here 10, and the next is null. So if it is gonna be null always, why I shouldn't make this default is null, so I don't need to pass, because most of the time I will be using null when I'm creating a new node. So I don't need to pass this one, or let it be there, it is just more explicit. So if I want to tie this one to another one, I don't need this second parameter, but for demonstration's sake I'm going to do that. So I will be creating, let's say, 20, and 20's next is null, so I don't need to put, that's it. So another node is created over here. Let me do that. So here it is. We don't know, in the heap somewhere this is created. And let's say this address, it is not consecutive, but I'm just gonna put here for us to remember D2. Okay, smooth this up. So the data in the first one is 10, and the next was null, still null, and this is 20. So I want to link them together. So how can I do that? I can say head, which is this pointer head. Its next is second. So what happened now? This is the head's next, and this will be second, which is this one, D2. It will be pointing. So we will be having this one to point to this one. And the next is null currently, but we will be creating another one. So this is cool, let it be there. I'm gonna just copy this one and create the third one. So this is second, right? Third one, and let's make it 30. Now I'm gonna link them together, so my second's next, not has second next, gonna be the third one. So I am gonna, let's have somewhere here another one. I'm gonna try to do with my mouse, and I will put, we didn't put anything, I will put 30 already. So 30 is next is null. I'm just gonna put n here. So second's next, now third, second next is this. It's gonna point to, I'm sorry, to this one. Let's say this is dynamic memory address 3, and we will put here dynamic 3. So all linked through this head, which is, this is the head. Oh my goodness, this is head, okay. So through here, and we, all of them are linked together. You may say, can you print all of them? Yes. How can I do that? I can just say while I don't want to lose this pointer, head pointer, because when we lose it, we cannot rewind it, okay? So I will be using one walker we call cursor. So I'm going to create temporary this cursor, which is actually on the stack. I'm going to say you are pointing the head, and then later on, while cursor is not null, which means you didn't come to the end. For example, at the very beginning it should be D1, later on D2, later on D3, and later on we will be null. So I'm gonna just come here and then say cursor. I would like to print the data, right? Say out. So cursor arrow data will be printed, and let's put here comma and semicolon. I'm gonna put here new line before hello world, so we can we don't on top of. So now if I leave like this, it will be infinite loop because we are not changing cursor. It will print always 10, but we would like to move to the next, so I need to update after printing cursor equal to cursor's next. So let's try to understand what is happening here. This is currently cursor, this one pointing this. Let's have here cursor. This is the cursor. We copied head to here, so it is pointing to D1. D1. Let's make this capital case D1. So I'm gonna use different color. So it is, we just copied from here data into this one. Now it is pointing to D1 too. So when I say cursor data, it will give me 10. I'm going to make this a little smaller. It will print this 10. Then later on when I say cursor next is D2, so it will become, it is going to point to this one. Then I will print the data, it will print 20. And later on say cursor next, this is the D3, which is this one, it will point to this one from now. And then next is null, so when after printing 30, next it is going to be null, and this will leave the loop. Let's run this one. So on the left you will see 10, 20, 30 is nicely printed. Of course this is in the main and this is not organized, and if I have a client who is going to use this code will really suffer. So we would like to wrap this into the linked list. So I'm going to create here called a class this time, linked list, and all these operations that we have been doing here, all of them, we will move up to here and hide, encapsulate everything here, and our user or client, main is client somebody else. So it will only just create an instance of linked list, and then later on add a search, print, all those things we will make. So this is a class. I will have public and private data members. So in the private data members, we will just need a head. We don't want anybody to mess with this. And in the public, there are functions we need, right? So we need first, let's say void add front function. Okay, we'll be making this one. So we'll be sending just a number which is into data. So this could be anything else in a string or anything. So we will be adding this. So for that, let me try to imagine how it is going to happen. We will say linked list, that is list, and then I will say list add front, come on. And then I will be adding some number to this one, let's say 10 again. So this will take care of all this stuff. But at first, what I need to do is, because I don't have any constructor, so I need to set the linked list head to null, because this means I have nothing in here. So head equal to null pointer. So it is null pointer, set it. So this is nice. So I will just come here. If it is the cases I need to be thinking about, if there is no item, then I don't need to be worried about. So I will just say if head equal null, this means nothing in it. I can directly do this. Head equal to new node and give the data. There we go. So now what I have done is we can simplify all these things. Okay, we can do some improvement, but I'm just gonna return. So if there's a single item, there's no item, now I'm done. But when I'm returning, so I don't need to worry about it. I don't need to have else here. So if there are more items, let's say I'm adding to the front. So let's say there is only one item now. I will be adding to the front. Let's move this one a little bit. This part, let's say this is our linked list, and I would like to add another one just in front of it. I need to link them together, right? I need to say point to this address, this one. So I'm gonna have this one. So what I will do is I will do in 2 stages and later on reduce to 1. So firstly I want to create this one. So node, I will just say this is a new node equal to new node, and with the given data. And the next is now important. Next will be this one, which is head. Okay, now I created this new one with the new data and linked to this head, because it was this one head. But now I'm gonna say you are the now head. Okay, now head was pointing to here too, so I'm gonna say you are the head. So I'm gonna do that. I'll just come here, say head equal to new node. I can make this single line, this code, halt code. I can say head equal to new node head. Sometimes it is confusing the students what is going on. This line processed, actually we don't need this new node, this parameter here. It can be automatically done in one liner, but don't worry about it. Let's see whether this is working, and we can add another one, 20. But of course, I can add another one. This time I'm going to add 40 to separate them. But of course, you say how am I going to access and print? So we need to have one more function, let's say print. And this will walk through all of them and print. We have already this function already, if you remember. I'm going to just copy this and put over here. And this is the head, cursor not, and it will print all of them. Let me put this time here, dash. Okay, so to separate them in one space here. So I need to call this list.print. Here we go, open close parenthesis, there we go. Let me actually comment out this part so it doesn't bother us. Okay, there's one, but we want one new line after this. See out end line, that should be good. So I'm gonna run this and we will see 10, 20. Okay, because we are adding the front, right? 40, 20, and 10. This makes a lot of sense, but if you are adding to the end, that is different. So this is so far so good, but only thing in here we were all the memory leak. because when you're using a new, you are supposed to do delete. It is good to have in link destructor all these things, but I'm gonna do void delete all memory. Okay, delete memory, let's say, and I cannot use delete key, which is a keyword. So what I will do is this time again I will be using the same structure like this, but I can use now head because I'm deleting everything. So delete memory, I'm gonna do this while head is not null. Okay, if it is null, we don't enter here, so everything is, there's nothing. So if head is not null, what I'm gonna do is before deleting the head, I need to get the next one. So I will create one node pointer called next, and I will just say next equal to head arrow next. So now I get the next data here. Okay, next node. Now I can delete the head. This is cool. Now I'm gonna set the head to the next, so it will move to the next item. So this should delete everything here, and then we should be seeing all memory free. So you may say, are you sure? Are we deleting all of them? If you like, we can have one destructor over here, and then say we can say node deleted. Okay, we don't need to worry about that. I'll just say cout, and I will say data deleted. So you will see \n is okay. So currently, of course, there is no, I don't call delete memory. It's not happening. I can manually call after print, and I try to print again. So list dot delete memory. I have one extra dot over here, and I'm gonna print. But if this is empty, it doesn't say in the print. If you want, we can say if the head is null, it is empty, so we cannot print anything. So I'm just gonna add this one just for the sake. If head is equal null pointer, okay, I'll just say cout link list is empty \n and return. I don't need to worry about it, right? So this is just for us. So I'm gonna print, I'm gonna delete, I will print again. So let me do debugging with F10. So we are adding all of them, printing. There we go. Let's zoom in. And I'm gonna delete all of them. 40, 20, delete it, and try to print. Linked list is empty. So this is working all cool. I'm trying to be in a, I'm rushing through. I don't want to spend so much time on this because you're also patience level, right? So this is if my customer forgets to delete, that is bad. So what I'm planning to do is, for the sake of safety, I will call this after my destructor over here. We don't have destructor, so I'm going to add a destructor here. Linked list. So this is the destructor, and I can call this function out of it. So if somebody forgets to delete, it will be deleted anyway. So do you want to test that one? Yes. So let's have some artificial scope over here. Just that's it. I don't need to delete this. So let's say I forgot to delete. Okay. So let's debug this one and see what's happening. F10. My list will be created here with this constructor, done. And I'm going to add front and print all of them, as you see on the left. Now I will, when I hit F10, this is goes out of scope, this is on the stack, and it will be calling the destructor here, and it will call my delete. I don't need to walk through all of them, it is deleted. There we go. So there is no memory leak. The second and last thing is, let's try to add to the very end. How are we going to do that? That is the challenging one. So I will have the similar function. This time we will be adding towards the back, okay, not the front. So in order to do that, we need to walk and all of them. And then when this is null, we should stop here. When this here, and then we need to have a pointer to this guy, because when we create a new one over here, this is two part, we will say your next is this. So in order to do that, I need to walk until the last node. So for that, we can again check if it is, head is null. I don't need to worry about it. If it is null pointer, I don't need to walk. We are the first one. If there's only single item, I'm thinking if there's only single item, I cannot walk much. So I can do this. If this is for, again, learning, head next is null. Okay, equal null. This means I have single, where is null pointer? Here it is. If I have single data, single node already exists. So what I will do is I will just create head, your next is the new node with the given data. So this is all cool. We can do always improvement on this one, refactoring, and then I will return. But if there are multiple of them, what I need to do is I need to be walking towards the end. So I will be using again the same mental model, like I will have a cursor like this. So if you see, I have return all the time, so I'm separate from it. The cursor is here. I might need more variables. While I will do this cursor next is not null, walk. Okay, so I'm trying to walk towards the end. So cursor equal to, as you guess, cursor next. Here we go. So this will walk if until the next is null. So when it is next is null, it will quit. So the cursor will be the actual last node here. So I can now last node, I got the last node. So what I need to do is actually last nodes next is the node that we are going to create now, and the data that we are going to give. That's it. So we don't need to update head because head is staying same. So cursor, that should be done. So when I run this one, I didn't run this one, but just to remind us, I was adding 40, 20, and 10, and I want to add 5 to the end, okay, after adding all of them. So we added here. I will be calling list add back, and I would like to add 5. Let's see whether this is going to work. So we have 5 at the end, and we are deleting from the very beginning, and 5 deleted. Looks like we are good. So that is in a nutshell linked list and node. I hope you enjoyed it. Have a good one.